Hi, good afternoon. So it's now the time of year when kind of everything has closed down and Christmas is 4 to 5 days away. And yeah, it's now the holiday seasons have started at Europe and virtually everything is just shut down. And only I think the emergency services and stores are open. I don't know how long they will be open. I think they should be till at least 2 days more until Monday or something. So today is Saturday and until Monday or Tuesday at the maximum, I think. So yeah, and then that's it. I think. Yeah, the reason I'm making this video is I many times observed like first I faced, then I've observed many people making their life very hard in PhD, and I just thought I had some things which I generally tell people or my friends to do to make their life easy and also their uh, things like organization of data or like plottings and things very easy. Like I think majority of the PhD time should be either for reading or developing knowledge or doing experiments, but at least it should not be wasted on a computer. What I feel like unless you are then like working on simulations or something related with data, but still not in waste tasks or rudimentary tasks which should not take more time. And I feel that many people unknowingly do this, and it adds up a lot of time and also a lot of brain activity or like just in general you need to think every time. So save your brains for that, don't waste your thinking in everything. So mostly I don't do that because only the things which I need that yeah I should think in this I do, and which don't I try to make things easier or automatic so that at least my life becomes simple. So one such thing, two such things I will say today. So one of it is okay. So I'll start showing my screen, or yeah, first take organization of files. Many people what they do. Okay, so I'll talk in an experimental aspect, but in simulation or theoretical aspects also you can I think feel this. Mostly in experiments, what we do is like I get some data from a machine or an experiment. I let's say I got it through a CD, I copy it at some folder, or I got it through the internet or some network. I download it. It stays in my downloads folder. Then I just plot it. I keep the plot somewhere. Then okay, in a week I do another experiment. I download it. I keep it somewhere. 2 weeks later, I'm doing work of another work, like let's say another topic or another paper, or another project. Then I keep it in like the same downloads folder over a period of time. Like initially this does not hamper your work or um, what is it, affect your work so much, but over a period of time, let's say 1 year or something, once you start experiments or doing PhD 1 year, you realize that oh no, you have a lot of data which is unorganized, you can't find it what's there. And so it's very difficult because um, now you have a lot of data, you don't know where the data is from, and is it correct data and which sample it is and such things. So the easiest thing to do is organization. So I'll show you one easy aspect of organization which I follow. Maybe you can follow another different technique or something, but at least what I suggest is that you organize your data. So here it is. Let's say I have a folder here. Okay, so I just create a new folder. One of my project, let's say, has with high entropy oxide is my topic. So batteries. Okay. So I just put HU batteries work or like project one, work one, whatever. I just named it like this. Okay. Then you have this folder. So always what you should do is like XRD. Put all the XRD data in here. Then you have like SEM. Put all your SEM results in here. Then also when you put the origin files, you just paste them or you create a new folder. say origin files, and you put all the origin files in this. So at least you know that this data is here. And let's say you have some electrochemical data or battery data, then you at least you would obviously run at least a couple of cells. So cell 1, then cell 2, and such. Cell 2. Then once you have done that, you have some, let's say, Word documents or something. Then you can create another folder, manuscripts, or yeah. So what happens is whenever you get a new XRD data, let's say you start with the experiment, you get XRD data, you add to this. You get the electrochemical data, you add to this. So after a period of time, your work becomes very, very organized because you start to open this HU batches folder and it's all your data. You don't need to go to some downloads folder or some, your old data, and you don't have to search among thousands of files. Your life becomes easier. And I'll show you how, like, one such work, how I did. And yeah, so you see this. I tried to do and do again. So this was the paper, and yeah, I just review, submitted docs, did figures, and such thing data. So I had here like electrochemical data, then TEM, TGA, XPS, XRD. So yeah, that's how I like organized it, and supplementary information. Then old files of origin, Raman, then and also the files like electrochemical data, EPR, Raman, XPS, and all these things. So once you have like very organized things, if I want a SEM data, I can just go SEM, and then I have the folders. Okay, this is the geo sample. Then I have the geo SEM image, RGO sample. I have the RGO images. So that's how easier it becomes. Then the second thing I want to say is like the origin software, how to use it. And many people have asked me many times, and I've tried to provide solutions. But then I thought I'd just make a small video to show how to do the origin and things so that everything becomes easier. Let's say I have this data. I'll start with some random data. Uh, XRD. Do I have any? Yeah, there is some XRD data. So I just plot this data. Let's say this is XRD data. Then geo. So once I plot it, this is the graph. So what ideally you should be doing is, or ideally what I follow at least, is that these numbers that are there, generally they come at size 18, or this is the size generally origin shows up. But when you provide this to a journal or something, it's okay. But from the size of the print that journal has, like if you take, I don't know, I was reading this paper, I don't know if it has graphs. Let us see. No, it does not. Let's see another paper. Yeah, you see the figure here. This is a bigger text. This is not. This is in Arial. This is in Times New Roman, and such things. And yeah, I'm not saying this is bad paper. It is good paper. I know that, but just that as a PhD student, you should not do this, because at least in India, generally professors are not happy when these things happen. It does not matter for a journal or for anyone seeing the data or something. Like, obviously you put it in Times New Roman or Arial or something, it's just 50 degrees or 60 degrees. it doesn't matter, but at least for some teachers it does. So, or for professors it does. So at least like make your life easier. Just and this does not have that many graphs. Ah, this was what I'm saying. So you have here this graph, and you see the numbers here. These are very small, and these are virtually invisible. Like these peaks and things, you can't see unless you zoom in. Like this is, I have downloaded the full size image, and I have to go all the way, and you see, you can't see what it is clearly. So this is a problem with, like, yeah, maybe when the person gave this figure to the journal, it would have been like a very good size. But the journal people, they reduce the quality of image, they reduce the size of image to fit their papers and things. So even if you see PDF of this, I don't think it would be good. Yeah, see. Okay, in PDF at least you are able to see, or yeah, at 100% this is not so good. But if you increase the text size or something of this, it would be very helpful for the reader to understand this figure. So, and similar with these things, yeah, you see 200 is at a different font size, 125 is at a different font size. You can read this one easily, not this one. Then these things are very easy to read. So there's a text difference between this and such that, so at least when you're doing, and same here 200, you see how small these things are. Try to avoid them. And I think like at least for origin, I kind of saw many papers and did many optimizations of these text sizes. I came up with something like, uh, okay, I'll plot this. So generally I tend to keep my this one at 30 in bold. Then okay, I'll plot this graph correctly. We don't need this, or okay, I'll just put this. Hmm, I think this is 002p, but I'm not sure. Yeah. So here this one, or you said this, whatever this is, you call it caption or something, just put it at 32 bold. Then this one, whatever you call it, inline caption or the name of peak or whatever, you put it at 30 bold. Then these numbers, these at 30 bold, and these things, the captions or the titles of access, these are at 32 bold. So generally if you follow this, you kind of have a good looking graph, at least, like which is visibly, you don't have to zoom in, or it is very good to see in, like your numbers are bigger, so you have this. And this size of, okay, oh, yeah, this size of the graph, like this line thickness, you can put it at 5, you can put it at 3, either works. Like if you have, you can visualize this according to how it looks. So 3 is also fine for this graph. For some 3 is not fine, so you have to go till 5. Or if you are plotting, like let's say line plus symbol, maintain it at 5, and this one at 12. Okay, so I put some other color. You can easily see like how it appears. So you put 12 for this one. If you want to have something, then let's say you want to have it as a drop lines, some graphs you want to have drop lines. Then for drop lines, generally in XRD reference patterns, you have to put like the drop lines. This time you just put it as 3. So now that it's a continuous graph, you have the drop lines, but for sometimes you don't have to like have these things. You'll understand once you plot the XRD reference patterns, you use these drop lines. And if you're putting a label, same thing, put it at 30 bold. So this was the idea or the general, like what I optimized from these publications and things, looking at the journals and how this appears in a small size, big size, and you don't have to use this, but at least go with bigger size diagrams. Then also you see now we have a border on four sides, this white space, this white space, this white space, and these things. There's a lot of white spaces here. And also if you, sometimes what happens, there's a normal plot, you plot a stack plot. I'll show you. I need another data. So I plot a stack, I just say 2 layers. So I'll put it half to this and half to this. Yeah, don't worry about this. I saved some templates and things, so that's why these captions and these come up. So you see the size difference, right? This is not at the same size of this one. Like if I copy this graph, I paste it, and side by to this, I paste this graph. Let's say you want to create a figure which has like A is this one, B is this one. You have to do all kind of bad resizes. You end up with something like this, where your, let's say, length or this side is equal, this side is not equal, and you can see visually, right? This is a bit horizontally longer, this is not. So what to follow in such cases, like when you have multiple graphs of different types, this becomes a very big problem, and in journal figures it does not look good. So what to do for that or for anything? So you have your graph 1, width always fixed at 11.37, 7.933. Then the first layer that you have, 17.9, 11.6, you put this at 6.597, 68.18, 71.79. When you use these measurements, then all your graphs, like I'll show you another, and here you can put something like 10. Okay, I just randomly put in 10. No meaning for that. I'll do the stack plot also. Eleven dot 37, 7.933. Then the layer 1 size I put here 3. Okay, I just need to, I don't want this shit. So okay, 71.79. Yeah. So now you see this look visually similar or something. So that's how you make this multiple type of graphs as equal. Wait, I think I messed up something. Okay, 68.18. Yeah, if you put the same dimensions from that one to this one, they generally match up and you have a very good looking figure palette. So this is one such thing where you need to focus. These are just things which improve your take less time. So once you do, you can also save this as a template. Like you just created this, right? You just go file, save template as, and you just put spec or whatever. So here you just do line. So all the line graphs that you come, they'll obviously come in this 30, 32, 32, all these dimensions. So that's good, easier for life. Then yeah, how to change this scale? There are two options in Audition. One is this increment, which is 10. So 10, 20, 30. Or you can do by major ticks. I want 9 ticks, or let's say 7 ticks. You understand the difference. So these are just 7 ticks. Then I want 8 ticks. So you have here 8 ticks, not 8 numbers. It automatically takes between these two and put it at 8. Or if you want to say like 10 randomly, I don't know, 9. Yeah. So these two are the things you can change with or play with. I think I think that's the thing to have, and I don't remember any such other things. Also, like these simple things, if you do it easily, your life becomes very easy, and you don't have to struggle every time to find the data, or to search for data, search among downloads folder or some other folders and CDs, everything. You just make your life simple. So try to do this, like, and also if you have like many XRDs, okay, I'll show you another one. I don't know if my Outlook will open. Hmm. Yeah, so I have an Outlook notebook, so you can use any search. You can use Excel, Word, or Evernote, or whatever notes book you use. So I have like all the notes here. Yeah, where I wanted to show a samples record I have. So XRD, like if I have folders by date, like my XRD operator or the XRD facility at my institution, they give folders based on date. So I have a folder called XRD here, and these are just based on dates. That's how they name them. So I have like 12, 8, 22. What does it have? It has one sample, and this is the sample. Like, okay, whatever used. So I just organize them so that I don't have to look through. I can just go to the samples record. Okay, this particular element, I can do a control F search, and then I know where the XRD or something lies. Then same with my electrochemical, like useless or use, don't consider this, whatever. So you have this. Then same, like what is sample number one? This is the date, which is the sample, and such things. So you can always use these things to make your life easier. Yeah. So use resources, I would say, just so that you don't waste time in unnecessary things. Use your time wisely, and if you have more time, enjoy life. Don't get into this searching on the computer every time you want to find a data, because I've seen many people who who initially don't have any trouble, but when something major happens, they are not able to find the data, and that's a very, what do you say, frustrating and hazardous thing when you are far long in your experiments and things. So yeah, Merry Christmas and Happy New Year. Maybe, I don't know. I don't think I'll make another video. I'm not sure. Bye.